Hello everyone, we are here in the first live session of this TA course, and I'm Titash Pramanik.
I'm Arjuna Dutta.
I'm Ravi Teja.
And we have one senior TA,
Myself, Deepika.
so we are here to help you out and to have a better understanding of the course. So you can feel free to ask us questions. We are here all to help you out. So we'll be waiting for your queries. I hope you all are enjoying the online videos, and it is well explained in the videos also. So if you are if you do not have any queries regarding that, we'll be happy.
We have
Feel free to ask us.
and of course live session and discussion forum. And hope you are enjoying assignments.
The following on given away for everyone like Symmetry and Structure.
We are having here some technical problem, but I hope this video is reaching to you. So we can see that 4 of you guys are waiting to write something, I guess. So please go ahead and write whatever the queries you are asking you.
You can actively participate in discussion forum also. Till now, we have received few queries and we have answered them well. And we want you to answer more questions. Like we want to ask you more questions.
Him?
One question.
But this is not the topic of the
It's not
Yeah, this is out of the
So, so Piyush Pant has asked about the lattice and ionic crystals. So yeah, it is a part of the course, but the thing is today it is not the topic that will discuss. So the discussion will be limited to the videos so far you have watched. So it's mainly up to week 4 and just assignments. So lattice energy and all at the end part of this course. So we first encourage you to ask questions uh, restricted to the week 4 videos and assignments.
Regarding assignment also, question. So,
Any other question?
So if you have any doubts regarding the point groups, crystal systems, its symmetries,
Bravais lattice.
Bravais lattices, why very specific types of Bravais lattices to each crystal systems, all these kinds of queries are very much welcome.
The chat box.
No question.
So we are still waiting for your queries. So please feel free yourself to ask us questions. Don't be shy. So like any basic questions you have, any kind of difficulty in understanding the crystal symmetry, you can please ask us.
Stereographic projection.
Yeah.
So, any problem with stereographic
So
projection?
if you have any problem in with drawing of the studio questions, we can help you how to draw them.
Equivalent point diagram, of course, symmetry, element
Yeah.
diagram, everything. Regarding n value, can one scale? Already we have
No, we
answered.
have answered, huh? So that's what we don't know exactly if we want to answer, discuss something which topic. For discussion forum also you guys have not mentioned which topics you are finding difficulties understand.
Regarding the m values, we cleared.
I hope so it's clear because I have written the example as well. So that no, that's what we are discussing. That m value why five-fold symmetric is not possible in the crystal system or three-dimensional space. So in this regard, I should mention you that is an object, particular object, it can have five-fold symmetry, but you cannot have full symmetry in space. Like if you have a pentagon and if you try to fill the base of a let's say any base or the floor, like the tiles having shape pentagon, if you try to fill that floor, you will find out there are empty spaces. So that is exactly one of the main results to understand this physically. Why can't we have five-fold symmetry in crystal system or three-dimensional packing? But an object or a motif, it can have 5-fold symmetry in between it. So a molecule can have 5-fold symmetry. A molecule which is having 5-fold symmetry can be arranged in 3-dimensional space, but the 3-dimensional space cannot have a 5-fold symmetry.
It's a cyclopentane.
So, and the mathematics that has discussed in this video, and we also have described it in the discussion forum. So, how it's found by the only the by the cos theta values. Only the restriction is cos theta cannot have value higher or lower than plus minus 1. So there is only the criteria, and all the mathematics is based upon this. And for different m values, you will have it, and you will end up with different theta values, and that theta values are the how much angle you should rotate by it. And if you divide that theta value, the 360 by that theta value, you will get the rotation fold axis. So if your theta value is, let's say, 180 degree, then if you 360 degree by 180 degree, then you will get that is corresponding to 2-fold rotation axis. If you get theta value is equal to 60 degrees, if you divide 360 by 6, you will get 6. That means it belongs to 6-fold rotation axis. So this is how, if once you get the theta value from that m equation, you will come to know it's corresponding to which rotation axis. And that is why we have only 1, 2, 3, 4, and 6 rotation axis in the crystal system, 3-dimensional crystal system. These irises, they crystallize in this molecules are having 5-fold symmetries, and people have solved the structures they crystallized in triclinic system. So there is no other symmetry, only one. So, but the molecule itself, the virus molecule is itself having a 5-fold symmetry. So the 5-fold symmetry is possible for the molecules or individual molecules or for the motifs, but it's not possible in crystallographic symmetry. So that point has to be clear. And we have, as we have discussed, that 7 crystal systems. So it's very easy to remember. You start from the triclinic, which is having no symmetry. So we got it only only one primitive Brachiolattice belongs to it. Next we have monoclonic. So the minimum criteria is it has to have at least one single 2-fold axis. By International Union of Crystallography, it is the B direction or the Y direction in crystal dimension, and you get a monoclonic crystal system which is having P and C, P is primitive and C centered, and other I centered can be again brought back to P centered. So that's how you ended up only 2 types of Brachiolattice in monoclonic, and is the criteria is only if you can see the monoclonic crystal systems. So you have A not equals B not equals C, alpha and gamma they are not equal, or B and equal to 90 degree, and beta is not equal to 90 degree. It can have any value. So that alpha and gamma to have a 90 degree value, this is coming because of the presence of the 2-fold rotation axis along P axis. This is the criteria. Now if you go to the higher crystal system, that's orthorhombic. In orthorhombic, you have 3 2-fold axes in orthogonal direction. You have in monoclinic, you have 2-fold in only Y direction or B direction. Here you have in orthorhombic 2-fold axis in A, B, and C, both directions. And as a result, you get alpha, beta, gamma, all are 90 degrees. It is the only possibility. Still, we don't have any restriction over A, B, and C of the crystal system. Only we have restriction on the A, alpha equals beta equals gamma equals 90 degree. Only 3 angles are restricted to have 90 degree values. And we have P, C, and A, all possible types of Brachiolattice present in the orthorhombic crystal system. And next, if you go to higher crystal system, let's say cubic. So a cubic crystal system, if before cubic, we should discuss about the tetragon, because here we have less restrictions. In tetragon, what you have A equals B, not equals C, and alpha equals beta equals gamma equals 90 degree. So we have got one question here.
Based on how to detect crystal structure of any molecule, and one more asked K4 FeC and REC in this crystal system.
Data responded.
BTEC.
ask the question.
How to find the isolation of a molecule?
So,
How to get the structure of any molecule?
that is what we'll ask. So question Rishabh, Piyush Pant, right? So Piyush Pant have asked again one question, that is this. I think the question is not well clear. So the thing is that how to determine crystal structure of a molecule would be the proper question. I think you want to ask that. So that's what you are, Piyush Pant. So you are, I hope you know the basics of the crystallography. You are keep on asking the next level questions. So we'll try to answer you in the next TA session. But the crystal structure determination is come in the last video of the full course, and you are asking about that has not come yet. So it will come. So see the videos, and I think it will be clear to you. And if not, then you can ask us. We'll be happy to answer you. But again and again, we are mentioning that this particular TA class is restricted to discuss about those things you have already seen or the assignment. So week 4 videos and this assigns week 4 assignment. So beyond that, we will not discuss in this particular TA session.
The second question.
Yes, sir. So
You can hear?
So question, sir, just rotate the camera.
Okay.
Database. I saved it.
So, and one more question Pishish Pant has asked about the crystal system of a inorganic system. So the thing is that if you think that we are Google, you are wrong. So that's what we have database where we can just enter this chemical formula and we can get the crystal system. But right now we don't have it. So if you urgently need it, so you can ask it in the forum, and we can reply it after looking at the ICD or ICHD database. We can give you the crystal system, the space groups of this particular and the lattice parameters of this particular system. But right now, sorry, we don't have it.
Even in the latter part of the course, sir has mentioned
About the
various
database.
type of database.
Correct.
So where this kind of question will be very relevant. So if you have this kind of doubt, please ask in discussion forum.
It's good that you are in an advanced situation. So that's good for us. We know some of the students will be like this. But the thing is, you have to keep patience. So we'll go through all the
We will
students.
answer this question in the forum. We will check this and answer this question.
So where were we? We were at the tetragonal crystal system. So we have discussed triclinic, monoclinic, orthorhombic, and then tetragonal. So in tetragonal, what are the restrictions we have? We have A equals B, not equals C, and alpha equals beta equals gamma equals 90 degrees. So that's why it came. It came because of the presence of a single fourth that makes A equals B. But the C axis is the direction of the fourth pole. That's what you don't have any restriction on the C axis. So as you have a fourfold along the C axis, your A and B lattice parameters has to be the same. So and you have alpha equals beta equals gamma equals 90 degrees. So these restrictions make you to have a tetragonal crystal system. Next is cubic. So in cubic, all we know is A equals B equals C, and alpha equals beta equals gamma equals 90 degrees. So here you have only one parameter, that is A. If you know A, you know B, you know C, and alpha, beta, gamma, you know that value is 90 degrees. So cubic is one of the simplest symmetry to understand, but a difficult, very difficult symmetry to recognize. Why? Because it's not the single three-fold or single two-fold anything that has to be there present in the cubic crystal system. It is the four three-fold axis as a parallel to the body diagonals or one direction. So these four three-folds, if you have in a crystal system in one directions or any body diagonal directions, then only you will have a cubic system. So you have, if you have gone through the point groups, you have seen that point group 233 that does not have any fourfold. So fourfold is not the uh, the most important rotation axis or symmetry in the cubic. What we think of, rather it is the this three or four threefold axis passing through the body diagonal, parallel to the body diagonal. So that's what you will get there. A equals B equals C, alpha equals beta equals gamma equals 90 degree. I hope you are getting this point. And apart from this, we have a trigonal system and a hexagonal system. So in trigonal system, you have at least one three-fold rotation axis along C axis, and in hexagonal, you have one six-fold rotation axis in along the C axis. So that is the difference between a trigonal system and hexagonal system. So in trigonal, you have only one three-fold rotation axis, but in cubic, you have to remember you have four three-fold rotation axis, and this is the primary symmetry that a cubic symmetry that should have. And the crystal symmetry, you know that there is in the cubic as A equals B equals C and alpha equals beta equals gamma equals 90 degree. Here 100, 010, 001. All these directions are equivalent. So that is why that equivalent points we talk about, equivalent symmetries we talk about, this comes up from the crystallographic symmetry. So now we want to discuss the why the beginning part. What you have after the crystal systems, you have the point groups, and the later part you will have the space groups. So in point groups is the nothing but the collection of symmetry about a particular point. So you have a point, and about that point or an origin, and about that you do or perform all those kind of symmetry that is are possible. That 32 point group. So that is why they are called point group symmetry. So they form a group about a point, and group means it has to be closed. In there is a definition in group in set theory, but here for simplicity, so we just restrict our discussion. So whenever we talk about a group, point group or space group, we want to mention that the group has to be closed or this have a closure property. So any point group that should have a limited or a particular number of equivalent points. It cannot have any number of equivalent points. It will have only a particular number of equivalent points, and that is why it is having coming from its closure property of that group. That is point group. That is why we are restricted to only 32 point groups. Any other point groups, if you want to build, we will end up with the same point group among this one of these 32 point groups. So that is why we have only 32 point groups. We cannot have any 33rd number of point groups. So point groups are also, if you follow, you have one bar in the beginning, then you have two m, then you have a 2 2 2. That is the, like say, the minimum symmetry for the orthorhombic, twofold for the monoclinic, one bar is for triclinic, as you know. Then you have three for the trigonal system, you have six for the hexagonal system, and you have that 4 3 2 and all this that for the 2 3 3. That is for the only six working now. Wow. For the hexagonal systems and trigonal systems.
In order to add some points to Titas's discussion, and Sir has told us like why only 32 point groups are there by showing us the proper axis of rotation, improper axis of rotation, and the combination of proper and improper axis of rotation, which follows the Euler's theorem. So you can go to the slides and you can check by yourself, and from there you will get the 32 point groups.
So on this 5 people they will write exam. Yeah. That's why.
No, he
will
knows.
answer the question.
He has been waiting to ask
Till
this
the
question,
last
I think.
part.
But we appreciate you, Piyush Pant. So, but sorry,
We
today's
will answer this question.
yeah. So
We will
today's
answer
session is not
discussion
for
for
this. So
It's
you
the
can
last question, K4 efficient.
so what you can do, you put that same question in the discussion forum. So and we'll get back to you. So today we thought we'll be discussing about the basic symmetry elements. point groups, crystal systems, and how
Brown rice lattice.
these point groups are those point groups are belong to particular crystal systems. All the relevant questions.
And
So
also the stereographic projection.
yeah. So let us draw few serial questions.
Like how many can
So
Yeah.
now one or two will see that like one bar the open circles, black circles, and that two-fold rotation axis is
you can do that.
so
So we'll tell you some few examples how to draw stereographic projection by taking the few system, one system from triclinic, one system from monoclinic, and one system from orthorhombic.
don't keep on.
I got it.
So you have let's say only one. This is you want to draw one group one. So what we do? We draw first a circle, and here you have, as you know, only one object. Uh,
Right, one is point, one
uh,
point.
So
Okay.
point group one. So you draw it like this. So you have exactly only one number of equivalent points, and there is no preferred directions in the triclinic system. It can be any direction, but any direction will have a one pole because it is having no symmetry. So let's say if you want to start from the origin here, there is no sign for it. I'm just for to make you understand I am drawing it. So you can see after 360-degree whole rotation, after it is going on, after 360-degree whole rotation, it will come again to here. So that is why it is called one pole. It is having no other symmetry. So in on the other hand, if we go for the monoclinic point group, let's say point group 2, then you have a sign for a two-fold rotation axis. This is like this. Uh, hmm, okay. So this is the sign for a two-fold rotation axis, and which is perpendicular to the plane. So it is going out of the that screen. So and in the monoclinic crystal system, we know it is the p-axis.
The rotation of axis is perpendicular to the board, that is through the direction you show there.
So this is the direction, perpendicular direction. It is coming
out of your
out of
laptop
the
screen.
laptop screen. Okay, and if you have the this how to draw it, so you have now two equivalent points. Right, I'll show you. So let's say here, if you have one equivalent point, then after 180-degree of rotation, you have a point, the same point. That is why they are called equivalent point. Equivalent point means whatever you have here, let's say it can be a atom, ion, any cation or anion, any molecule, group of molecules, whatever is your motif. If it is something is there, and if there is a presence of two-fold rotation axis, it will go by 180-degree and it will come here. It is position here, and this is the y direction is this one. This is coming out of the board of the plane of the board, and again by two-fold rotation axis, that is means 180-degree, you will go back to here. So that is why in a two fold or point group 2, you will end up with the having two equivalent points. They are related by a two-fold rotation axis parallel to the b axis or y axis. Here it is perpendicular to the plane of the board. Let's say the board is our AC plane, so B is perpendicular to it. So that is why it is comes like this. Now, if you want to go Now, if you want to draw the minimum symmetry for orthorhombic, let's say 2, 2, 2, then what how will do? Now we have to consider about the three directions. So very bad. Huh, everything. Yeah, it looks like that. So we will start as we have started in the case of monoclinic. So we have a two-fold that is parallel to the board, perpendicular to the axis of the board, and you have two equivalent points like this, two equivalent points. Now you have a two-fold axis along the B direction, and we have told that the screen is or the this screen is like AC plane. So now if we have a two-fold along this direction, let's say perpendicular to this, let's say this is our A direction and this is our C direction, and this is the direction which is coming out. This is the B direction, perpendicular to A and C. So by using the two-fold rotation axis parallel to B axis or perpendicular to AC plane, we have got two equivalent points, this one and this one. And now if we have a two-fold rotation axis parallel to A or along the A axis, then this point will come here, right, as a two-fold rotation axis, and this point will go there.
Till open circle.
I'll tell you. First, let me know. So now you can see now that the these points which are this point and this point both were above the AC plane. Let's say if we start with a point that is above the AC plane, so both these points are above the AC plane. So let's say B equals to positive direction, 0 to positive infinity. In that direction you have a point, and AC where the B cuts the AC, that is 0. So if you have a point or any motif that is above your AC plane, so that we represent as a disclosed circles or this dark circles. But now if we see the twofold, when we apply the twofold which is parallel to A axis, now that point which was above the now AC plane, it will come now down below the AC plane it will go. If you have a twofold here after the 180-degree rotation. So to represent this uniquely from this point, to represent this point uniquely from this point, so what we do, we present this one, represent this particular point as an open circle. So that is why we have two different. If you can go through the point groups, stereographic projections, you will see there is a field circles or the closed circles, and you have an open circle. So as it is gone out of the plane, so that is why we will represent it as a open circle. Same will go for this one as well. So I hope it is clear to you when to draw a open circle and when to draw a closed circle. So remember, whenever you are switching the plane, let's say you will start from a direction and you have you are drawing on a page, so your page will be on plane. So if you are assuming in the beginning that your point, your motif is above that plane and you are drawing, and by virtue of the symmetry elements or in operation after the operation of a symmetry element in any other direction, if that particular point is going below that plane, then you have to mark it as an open circle. Same goes for the inversion center. If you draw one bar, in one bar you have two equivalent points, but one is above the plane, that's say x, y, z, and one is below the point, minus x, minus y, minus z. That you any point, any plane you can consider. If you consider xy plane, then in one case you have minus z, in other case you have plus z. If you consider xz plane, then in one case you have minus y, in one case you have plus y. So in one bar point group you draw, you will get this the symmetry equivalent points are x, y, z, and minus x, minus y, minus z. So you will always found that one point is above the plane and one point is below the plane. So one will always be closed circle and other one will always be a open circle. So that's what this is a very important part of the crystallography you should know. That is the because these are the grammar of crystallography. We say in crystallography. So these are like a language have alphabet. So we have this grammar. So how to represent? Because this is a uniformity you have to maintain in representation. Otherwise, whatever you want to convey, other people will not understand what you are trying to say.
And
So
sometimes we are mentioning cross instead of closed circle. So
yeah.
both are same.
So clause and both
In some
circles.
books
Yeah.
you will get that convention.
Yeah. So in the these are the books came before the IUCN, I guess. So that's what they
Actually,
have.
in the presentation, we are using the cross and open circle, but you can use the closed circle and open circle as well.
Yeah. So as she mentioned, so cross also will find. So that's what the people also thought of having using a different thing before the IUCR also. But after IUCR came, they have restricted. That's what whenever you will see the IUCR that's for the space groups, there you will find out basically that with a plus sign and with a minus sign and all those things. So that is above the plane or below the plane like this. So I think that
Any questions?
we are.
Conversion from one premise lattice to other, it will be clear to them.
Yeah.
Uh,
So because those pictures and also they are present
Yeah.
in the video, so we
Still, if
believe
you
that
have doubt,
you can ask us. There is no issue, but it is well described in the PPTs. So,
why P and I is there in tetragonal, why not A and in syndrome?
so we are thinking of closing this.
Green, if they ask any question, you cannot see, right?
Any questions? Where it's gone? In your YouTube there? No. So far we have not received any further questions. So we thank you. So please ask if you have questions in the discussion forum. Uh, Shushpant also you can ask us those questions in the discussion forum. We can reply you back and see you on the next
Next
live session that we will update you soon.
Bye.